Welcome to lesson number 5. We're going to look at composition of functions. Now, a composite function, usually referred to as h of x, can be written in the form h of x is equal to g of f of x, and we would read that as g of f of x, or we could say h of x is equal to g of f of x. Now, we're going to look at a few different examples of what that means for our function. And so let's look at class example number 1. I have the function h of x is equal to x squared minus 2. We want to describe in words two operations that can be applied in order to x. So we end up with x squared minus 2. So first we would square. And second, we subtract 2. Now, if I'm completing this diagram for h of x as a composition of the two functions, f and g, where h of x is equal to g of f of x, then the first thing we did to function f was we squared it, so that would be x squared, and then we subtracted 2 with function g, so that my final function was x squared minus 2. So that means that function f of x, so f of x was x squared, and function g of x squared was x squared minus 2. So that means function g of x must be x minus 2. Now, another way we could do that is in option 2. We're actually doing the exact same process that we just did, but describing words two operations in order. So in order to x, which can be applied to end up with x plus 4 cubed. So first of all, first we would add 4, because we're taking care of what's inside of the brackets first. And second, we would cube. And so first we're adding 4, so x would be x plus 4, so add 4, x plus 4. And then second, we were cubing, so cube, which would be x plus 4 cubed, which means f of x is just x plus 4, and g of x plus 4 is going to be equal to x plus 4 cubed, so that g of x must be x cubed. Now, with our composition of functions, if we consider this, g of f of x is equal to g of f of x, where f of x and g of x are given, we want to use this procedure. So, if this is what we're working with, we want to start with g of x. This is one way to do it, by the way. It's not necessarily the simplest way, but we would replace f of x with the formula for f, and then we would apply the formula for g, and then we would write in simplest form. So what this looks like, so if I have g of f of x, I would have g of 10x plus 1. And then I would apply the formula for g. So remember, the formula for f of x was 10x plus 1. Formula for g of x is 2x minus 5. And so I started with g, so g of f of x, and I replaced the x term with f of x, which is 10x plus 1. But then I applied the formula for g of x. And so the formula for g of x was 2 times, so the x is 10x plus 1 now, minus 5. And if I expand this, we're going to get 20x plus 2 minus 5, or 20x minus 3. So two examples, if f of x is equal to 2x squared minus 1, and g of x is equal to 3x minus 4, we want to find g of f of x. Also, g of f of x. So what we're really asking here is what is taking the place of the x term of the outermost function. And so another way to do this that is different from the book is we start with the inside function. And so in this case, my inside function is f of x, just like it was before. And so I would start with my inside function, which is 2x squared minus 1. And so that's the inside. So this is taking the place of x in function g. So then I would fill in the outside, which would be 3. This is the x, and then minus 4. And so if I expand this, this is going to become 6x squared minus 3 minus 4, or 6x squared minus 7. And that would be my final answer of g of f of x. Now, g of x, again, we're going to be starting with the inside function, which is 3x minus 4. And then we're filling in what's around it. So same thing before. Around it is going to be 3. This is my x term, and that is what comes after. And so if I expand this, we're going to end up with 9x minus 12 minus 4, or 9x minus 16.